All right, so here we go. Combinations of functions. So we are dealing with functions. Here's what we're going to look at. We're going to look at adding, subtracting, multiplying, dividing functions. This is just basically adding, subtracting, multiplying, and dividing polynomials. Shouldn't have any issues with that. Compositions are a little bit more confusing, but basically it's just a substitution and simplification. And then we'll look at a model of a real life problem that uses this. So, arithmetic, combinations of function. Arithmetic, we're talking about adding, subtracting, multiplying, and dividing. All right. Just as two real numbers can be combined by the operations of addition, subtraction, multiplication, and division to form other real numbers, two functions can be combined to create new functions. So here we have two functions. F of x equals 2x minus 3, and g of x equals x squared minus 1. All right. If we want to find the sum, and I'm going to sort of go over to the side and not use the one that they've done there. The sum of these two functions would simply be, I could write it as two ways I could write it. I could put f of x plus g of x, or you may see it written as f plus g of x. So the first thing, please be aware that those two statements mean the exact same thing. Okay. Yes.
I can't see your screen.
All right. Let's see what's going on. Okay, so now I've got everything shared through Zoom. So f of x plus g of x simply means that you take whatever f of x is, 2x minus 3 in this case, and I'm going to add it to whatever g of x is. I like to go ahead and put them in parentheses to keep them separate. And also when we subtract, that will help. So now it's just a matter of simplifying this. Okay, if we have a polynomial in parentheses with nothing in front, it's just like an understood one that I'm going to distribute through. When I multiply everything by 1, nothing changes. So basically what I have is 2x minus 3 plus x squared minus 1. And then we're just going to combine like terms. And I'm going to go ahead and put it in proper order with the highest degree first. So x squared, the only thing that's going to combine are the constants. 2x has nothing to combine with. And then negative 3 minus 1 is minus 4. So there's what I get. And that's what they get over there. All right. So when I'm adding functions, that's all I'm doing. I'm just adding and combining like terms. That's all it is. Okay. Let me see if they go into. Yep. Now, if they want subtraction, okay. Once again, this could be written as, and it is very important what goes first. Okay. With subtraction, it matters. If that were g minus f, you're going to get a different result than if it's f minus g. So what that tells you is you take the f function first, which they've done there, 2x minus 3. And we are going to subtract the x squared minus 1 function. Now, here's where we have to be careful. Simplifying, getting rid of parentheses. This one's no problem. It's just an understood 1 in front of it. When I distribute that, would be 2x minus 3. This one That is like a -1. So you do have to make sure that we distribute -1 through that, or basically change the signs of everything within that second parentheses. So that would become -x squared plus 1 when I distribute that -1 to both of those. Now the same thing, I'm going to combine like terms. -x squared plus 2x, and this time -3 plus 1 is -2. So there is the subtraction of those two functions right there. Okay. Once again, this is algebra 1, algebra 2 type stuff once you get doing what we're doing, combining polynomials. All right. I don't know what that little symbol is right there, but they're talking about multiplication. So let's slide over to the side here and talk about multiplying these two things. Once again, it could be written as f of x times with a dot g of x, or you could see it written as f times g. Now that is when we get to compositions, they'll use a little open circle. So make sure that is a dot, not an open little circle. It means multiply. So we're going to take our two functions, which was 2x minus 3. This pen won't write on here very good. Times x squared minus 1. All right, so if we're looking at two binomials here, this is where some of you may have learned FOIL. I just teach it where we've got to distribute each term in the first parentheses throughout the second parentheses, right? Okay. So I'm going to take 2x and distribute it through. So 2x times x squared would be 2x to the third. 2x times -1 would be -2x. -3 times x squared would be -3x squared. And -3 times -1 would be +3. Now notice, nothing will combine to simplify, but I do want to go ahead and rewrite this in decreasing order by degree. So I'm going to go ahead and rewrite this as 2x cubed minus 3x squared minus 2x plus 3. Check that on WebAssign. I assume it may accept the answer regardless of the order, unless it does tell you to put it in standard form. Standard form is decreasing by degree. All right, anybody with any questions, anything? We're good. This is pretty straightforward stuff. And then let's see if they do show us the quotient. And I'll do this right over here. F of x divided by g of x. And I guess you could see this written as f over g of x. But basically, all we do here is we write it in a fraction. F was what? 2x minus 3. So the 2x minus 3 is going to go in the numerator. And then the x squared minus 1. All right, if it would simplify, you could factor and simplify, but that nothing's going to simplify there. The one thing you do have to put, though, is because now we have a denominator, a variable in the denominator, we do have to list what x cannot equal, right? Remember, we cannot let x or the denominator be 0. So what two numbers would cause that to be 0? Well, if I substitute in 1, 1 squared minus 1 is 0, so x cannot be 1. Also, because it's squared, if I plug in -1 for x, -1 times -1 is +1. 1 minus 1 is 0. So I would have to put that in right there. Okay. So this adding and subtracting, multiplying and dividing really doesn't get any more complicated than that right there. So we're not going to spend a whole lot more time on that. Y'all should be able to add, subtract, multiply, and divide polynomials together. That's just what all that's saying right there is what we just said. That denominator cannot be equal to 0. G of x cannot be equal to 0, and you have to list and exclude any x's that would cause that to happen. All right. All right, right here, we look at this, they're doing the same thing. Notice they wrote it as find f plus g of x. But the second thing they want you to do is to evaluate the sum when x equals 2. Now, there's two ways you could actually go about doing this. You could take and substitute 2 into each function separately, simplify it down, and then add the two together. Okay? Or do what they're asking us to do right here, which I'm sure on WebAssign, they're going to set it up so that you have to go ahead and combine the functions first. So adding f of x and g of x, notice we have 2x plus 1 plus x squared plus 2x minus 1. Combine like terms, x squared, 2x plus 2x is 4x, and then 1 minus 1 is 0. So I'm left with that function value of those, the added function value of x squared plus 4x. And then if they want to know the sum when x equals 2, they're just basically now you're substituting 2 in for the value of x. We are finding f plus g of 2, which now there's f plus g of x. Now I'm going to plug 2 in for x in both places. So I'm going to have 2 squared plus 4 times 2, which is what, 4 plus 8, which is 12. Okay, so just an added step there. Let's see if they do it with, no. Same thing if you were to subtract, multiply, or divide, you would find the function value and then substitute the value in. All right. Now, compositions of functions. This tends to give people a little bit more trouble than that other stuff. Another way of combining two functions is to form the composition of one with the other. So here's our two function values. F of x equals x squared and g of x equals x plus 1. The composition of f with g is, notice how they wrote that. All right. F of g of x is how you would say that. And essentially what that means is we're going to take the value of g of x and we're going to insert it into the f function. The other way that you can see this written, let's see if this pen will let me do this, is f and then a little circle. It almost looks like it says fog, but that is another way to write the composition. And the order matters here. The second one is getting inserted into the first one. So if you can see what they've done, so what we do is we are going to take f of x, which is x squared, and I am inserting whatever g of x is in for the x value in the f function. So what I actually have is, what's the g function? X plus 1. All right. So the composition f of g of x is equal to x plus 1 squared. Now, if I did want to simplify that, how would I simplify it further? Is I would have to write x plus 1 times x plus 1 is what x plus 1 squared is, and then I would multiply it out. X squared plus 1x would be 2x. And then 1 times 1 is 1. So this is the simplified version of what that is. All right. Now notice, if I went and were to flip that around and say, okay, find g of f of x, notice the difference. G is x plus 1. And what I'm going to do is I'm going to replace x with the value of f of x, which the value of f of x is x squared. So what I end up having is I replace x with x squared. So there is the composition of g of f of x right here, whereas f of g of x is this right here. Okay? And there's the denotion with the f, the little circle of g, and then you read that as f composed with g. Okay? You could say f of g of x or f composed with g is how you could speak it. All right, one little definition of composition. The composition of the function f with the function g is what we just talked about. The domain of the composition is the set of all x in the domain of g such that g of x is in the domain of f. All right, and that's a little bit wordy and hard to visualize as it's written. But it cannot be in the domain of the f if it's not in the domain of g, and we'll look at an example of that here in just a second. All right, here's one. They're talking about where we got to worry about a domain. So we've got f of x, and I'm going to rewrite them over here, equals the square root of x, and g of x equals x minus 1. Now, they say this part right here, x has to be greater than or equal to 1. Now, why are we having to say that? Well, because we're only dealing with real numbers, and we cannot find the square root of a negative number, right? Now, normally, the square root of x, I'm sorry. There we go. X is greater than or equal to 0 goes with that one. I skipped over that. So x is greater than or equal to 0 is covering this. This is actually going along with the composition, is why we have to end up putting that. So let me show you. If I do the composition of f composed on g, right, that means I'm going to take out x right there of f, and I'm going to put in what is equal to g. So it would be the square root of x minus 1 is the composition. There, now because we've got x minus 1, that's why we've got to include this one right here. X has got to be greater than or equal to 1. Anything less than 1 here is going to cause this to be negative. All right, so that's sort of what that's saying is you have to sort of combine the two to look at the actual domain. Just because the domain for f of x is one thing doesn't mean the composition is going to have the exact same domain. The domain could change. All right. Then it asks us to find f of g of 2. Well, if we're looking for f composed on the g of the value 2, that means we're just going to plug in 2 right there, right? 2 minus 1, square root of 1. And are they going to include both the positive and negative with that? They're just looking at the positive of it. All right, so that equals 1. All right. Notice if I do f of g of 0, I'm going to have square root of 0 minus 1, which is the square root of -1, which does not exist for real numbers. All right. Now let's look and sort of, there's where they did the composition right here. That's exactly what we got, the square root of x minus 1. X has to be greater than or equal to 1. Notice they just looked at the graph of it also and shown that the domain, and they use interval notation right here for the domain. Here's what that graph says. Okay. It's basically half a parabola on its side, started at 1 and goes to the right forever. So that is the domain. It includes 1. Okay. And then it just states again, like we just said, f of 0 is not defined because it's not in the domain. All right, so let's look at one problem here that sort of adds an application to it. All right, the number of bacteria in a refrigerated Petri dish is given by this quadratic right here. N of t, 20t squared minus 80t plus 500, and here's the domain they're using. T has to be in between, or is somewhere between 2 and 14, or including 2 and 14. T is the temperature of the Petri dish. Okay, so T is the temperature. That's important. When the Petri dish is removed from the refrigeration, the temperature of the Petri dish is given by, so once they take this dish out of the refrigerator, obviously it's going to start warming up. And here's the rate at which it warms up. Okay, notice they use a small t there. All right, because time, little t is time. It's not, that's why they had to use a smaller t to separate them. So between 0 and 3 hours, it will tell you the temperature of the Petri dish. All right, so if I pull the Petri dish out for 2 hours, then I would put 2 in for T. That would be 8, 10. The temperature would be 10 degrees Celsius, 2 hours after the Petri dish is out of the refrigerator. All right, so what they're going to do is they're going to create a composition, because the number of bacteria is dependent on the temperature, which is dependent on the amount of time that it's outside of the refrigerator. So ask us, look at what they ask us to find. They ask us to find N of T. So we're going to take the N one, and we're going to replace, let me get a highlighter here. We're going to replace the T's with 4T plus 2. Does that make sense to everybody? Because I'm putting the temperature into the function for the number of bacteria. So as I write that out, it's going to be 20. And then I'm replacing T with 4T plus 2. And that's squared minus 80 times 4T plus 2, and then plus 500. All right, so that's what I took the composition of this into this one. So wherever T was, the big T, the temperature was, I put in what gives me the temperature, 4T plus 2. All right, then we need to simplify this out. So there's a little bit of work involved here. So I'm going to have to take 4T plus 2 and multiply it by itself, right? Minus 80 times 4T plus 2 plus 500. So let's start simplifying now. getting rid of some parentheses. I'm going to go ahead and multiply this out before I multiply it by 20. So I'm going to leave that 20 right there. And this is going to be 16t squared plus 8t plus 8t, which would be plus 16t. If you can't do that in your head, go ahead and write out 8t plus 8t, and then 2 plus 2, or 2 times 2 is 4. Here, I'm going to distribute a negative 80, so that's going to be negative 320t minus 160 plus 500. Now continue to simplify. I've got to distribute my 20. So 20 times 16 is 320. So I've got 320t squared plus, that's going to be 320t. And then 20 times 4 is 80, plus 80 minus 320t minus 160 plus 500. All right, so notice the positive 320t minus 320t cancel out with each other, so I'm going to be left with 320t squared. All right, and then 80 minus 160 plus 500 equals 420. And hopefully I did that right. So we get that composition as 320t plus 420. Let me see, go down here and see that I did that right. I missed a sign somewhere. That should be 320t plus. No, they did it wrong. Notice when they added, they got 500. They're saying 80 minus 160 is 0. So we are correct. The book is wrong. So what we have is 320t squared plus 420. Right? That's one thing about this book is several of its PowerPoints have some mistakes. All right, so that's the composition of N and T, T to the T, whatever. It's harder to say when it's different things other than G and H or G and F. Okay, so this is what we were looking for there. So that's what we answered. We answered the A part. All right, the B part says find the number of bacteria in the Petri dish when T equals 2. So simply, here's T. All we've got to do is to find the number of bacteria, we've got to substitute 2 in for T. So we're going to have this right here, 320 times 2 squared plus 420. And I'm just going to punch that in the calculator. 320 times 2 squared plus 420 equals 1,700. So there are 1,700 bacteria in the Petri dish when it's been out for 2 hours. All right. Then the last thing is find the time when the bacteria count reaches 2,000. So what it's wanting on the last one is it wants to know when will this be equal to 2,000. So notice what I'll do for the C part is I'll take 320t squared plus 420, and I want to know at what time will that reach 2,000. All right, so this one I want to subtract 420. So 2,000 minus 420 is 1,580. So I've got 320 t squared equals 1,580. And then I need to divide by 320. I'm going to write that as a simplified fraction. 1,580 over 320 simplifies to 79 over 16. And then to solve for t, whenever we have t squared, we just simply take the square root of both sides. And then I'm going to put an approximation because I'm just going to take the square root of 79 over 16. And that is about 2.2. Now that's 2.2 what? The question was, find how much time will it take for the bacteria count to reach 2,000? So once this has been pulled out of the refrigerator for 2.2 hours is when the bacteria count will reach 2,000 in that Petri dish. Okay? So just to review what we did is for the composition, we took the temperature formula and substituted it in for the T in the number of bacteria formula, simplified it all down, figured out that the book did it wrong and got the wrong answer there. And then they wanted to know, okay, what happens in 2 hours? You plug in 2 for T. And then they wanted to know, well, when's it going to reach 2,000? So then we had to solve for T to get it there. Okay. So, and we'll ignore that because that's all. Well, they ended up getting it right. They corrected it down there. Somehow they skipped from there to there. And they ended up getting it correct. All right, that's all I got there. They're just looking at a graph of it, which really doesn't help us a whole lot. So I will open up, what is this, 1.5 on WebAssign. And if anybody has any questions as you get going, just let me know.